So let's get to these protocols. Certification of TPM keys is one of those complicated and frustrating topics because the TPM working group created these beautiful, high security, verifiable protocols with lovely properties which tell us everything we really need to know about TPM keys and are completely incompatible with every standard that anyone's actually implemented. Arg. So, what this means is that today's commercial CAs, if you attempt to use these protocols with them, or if you attempt to use a TPM credential, it just won't work. It's not even that they'll fail, it's that they're completely incompatible. You cannot use TPM keys in standard certification protocols, except maybe for a signing key, but even then, you get no assurance out of it, because how do you know it's a TPM key? You don't. So, standard certification protocols just don't serve for TPM keys. So let's talk about how we can certify TPM keys. So the TCG certification design is worth talking about because it's very elegant. It gives us all the properties we need. The only problem with it is that nobody supports it. Then we'll talk a little bit about the enterprise PKI world, commercial CAs and what they expect, and then how we recommend and anticipate going forward to try and meet these two in the middle. So the vision at the high level that the TCG has come up with is we have a TPM endorsement credential that's certified by the manufacturer, as we mentioned earlier. An identity key is tied to the endorsement key with a lovely pseudonymous protocol called the privacy CA protocol. In as much as it's called anything, it's sometimes called an AIK protocol. It doesn't really have a name. Identity keys can then certify other TPM keys using things called certify key certificates. And at every single step of the way after that manufacturer certification, there's a very strong cryptographic binding. I have proof that if that's a good TPM, and the manufacturer said it was, there is absolutely no way that I can accidentally certify another key and think it's a TPM key when it's not. And I can build beautiful hierarchies that don't require a CA to certify every single step, because the TPM can self-certify new keys. So I can do transient keys without any concern that a CA is going to issue the wrong thing or any worry about particular revocation lists. And anyone who receives a TPM key certificate can, in theory, trace back the entire architecture and confirm this is a genuine TPM key and I know why and I trust it. The TPM basically acts as its own CA for its own keys. And it won't certify anything else, so you can trust it. Well, let's just say that the world doesn't like that. So I've talked a little bit about this identity key certification protocol. And it is a thing of beauty. It is extremely simple, extremely straightforward, and extremely non-intuitive if you're not used to this sort of thing. The way it works is we have an endorsement key and an attestation identity key. And then in this case, these are both public keys that are encrypted to the privacy CA. And we're going to continue calling this privacy CA, even though in an enterprise context, privacy is not really the concern, because this tells you what kind of protocol it is. We just call it a CA. People often get confused. The privacy CA evaluates the endorsement key and says, is this an endorsement key that I trust to be from a legitimate TPM? That bundle may include an endorsement credential. It may come via a separate channel. We don't really care. If it trusts the endorsement key, it will issue a credential for the AIK. It doesn't evaluate the AIK in any way, shape, or form. It got handed an endorsement key, a public endorsement key, and a public key that it supposedly is for an identity key. And it will issue a certificate saying that AIK is a legitimate TPM AIK, and it will sign it. It will then encrypt that certificate to the endorsement key. This is the one thing the endorsement key does, is when that encrypted blob gets to the TPM will say, is this AIK loaded in this TPM? If it is loaded, which is to say we know that it's our key, then the endorsement key will decrypt that package and unlock the certificate. Which means that later on, if that certificate is ever used, we have proved that that endorsement key unlocked that AIK and that therefore that AIK belongs to a legitimate TPM. Because we issued the certificate knowing that the endorsement key was legitimate, and the use of the certificate proves that the endorsement key is on the same machine as the AIK.
Ask a question quick.
So, no, please do.
Let me make sure I was understanding. Did you say there was a evaluation step where, when the TPM gets back this encrypted certificate, which is encrypted with the endorsement key, did you say it's checking if the endorsement key is loaded or if the AIK is loaded, or what sort of check does it?
It's checking if the AIK is loaded.
But that certificate, is that certificate being, so as this protocol is shown right now, it was saying that the certificate is encrypted with the endorsement key. So is it decrypting it and then checking it, or is there a plain text AIK there as well?
There's a little bit of a wrapper in there that I'm hand waving. But basically, it is, so this is one of those cases where there is a little bit of a, how much do you trust your CA? A CA can, the way this actually works is there is a symmetric key, which is in a wrapper that says this symmetric key is associated with this AIK's public key. And that is what is actually encrypted to the endorsement key. So the endorsement key decrypts it and says, given this bound data and this here public key, if this public key is the one from the AIK that I have loaded, then I will return the data that I've just decrypted to the user. And that returned data is what unlocks the actual credential, because the credential is a little bit big. But fundamentally, yes, the endorsement key decrypts it, checks the AIK, and if the AIK is legitimate, returns the data, and if not, it just returns an error. It doesn't give anything back.
Okay, just wanted to make sure I was clear on whether there was a decryption initially or whether there was an extra plain text part or what.
There is a decryption initially. The plain text is not something we're relying on here. It says pay modification text. So are there any other questions here? Because this is a very confusing protocol if you're not used to funny decryption operations.
So you have to distribute the symmetric key first as part of the trust?
The symmetric key is not, there's no trust involved. The only thing the symmetric key is being used for is a certificate is big, a symmetric key is relatively small. The certificate is encrypted with symmetric key. The symmetric key is what's actually encrypted to the endorsement key.
No, but I mean, in order to get this started, the TPM first have to have either the public key or the PCA?
So yes, something on the TPM side needs to have the PCA's public key.
Okay.
The TPM will generate that first request automatically when you do make identity. Remember how I said it takes a public key for a certificate authority that generates a certificate request with? The TPM will generate that automatically, but you can also generate them in software. And part of the reason we call this a privacy CA is you will note that the PCA has no actual guarantee that the AIK is associated with the endorsement key. So the way that this is envisioned, if you're actually trying to get pseudonymity out of it, is that I can issue 50 certificate requests and only decrypt one of them. And the PCA doesn't know unless it sees the credential which one was actually legitimate.
So the PCA would have to have some knowledge of the EK on the public side, right?
Yes.
And TPM would have to have the public for the PCA. So if you start off that way, then I can see the rest of
We are assuming that the PCA either knows about the endorsement key or has a credential.
So that was a prerequisite to get this handshake started.
Yeah. The other thing that is really critical to note here is that the trustworthiness of this protocol is dependent on that original certificate for the AIK not being public, because its decryption is what proves something, and that's where things start to break in the public world. Any other questions before we move on?
Sorry, can you say that one more time? So in the initial part, there's the EK. So I got that the PCA and the EK, each side needs to know the public key. But the AIK, yep, you're not passing the public portion across to the PCA?
You are.
Okay, so you're just saying the private portion is, that's the full assumption is just private.
No. Okay, so the AIK, right, the private half never leaves the TPM, except encrypted. When we talk about AIK here, that's the public half. What I'm saying is there's that phrase here, that cert AIK signed by the PCA, that is encrypted to the, yep, EK. Yep. That second message, the association between the AIK and the EK is dependent on performing that decryption operation. That means that if the CA publishes that certificate, we no longer have a cryptographic binding because someone didn't need to do the decryption. And most CAs treat certificates as public information. There are CAs that will, the first thing they do with a certificate is they publish it on the web, because certificates are public. And the answer is this certificate is public once the EK has decrypted it. We can just present it like any other certificate. But before then, it actually needs to be treated as secret. And this is a reason that we can't just do a shim of some kind on a standard CA to run the privacy CA protocol, because if that credential ever goes public, we lose the assurances of this protocol.
The fact that you didn't decrypt it in the PCA, you can rely on the fact that the TPM is the only thing that has the knowledge to do that.
Exactly. Exactly. The TPM had to get involved, and the TPM would only do that if that binding was there.
Yep.
So, once we've got our identity key, we can start talking about certify keys. The TPM certify key command issues a certificate for any non-migratable TPM key. There is a certifiable migratable key where you issue certified migratable key certificates, and we are not getting into that today because it's complicated. This actually meets the vast majority of our needs. Any non-migratable key, a certified key certificate says, this is a genuine TPM key that has the following properties. And the certified key credential includes the key type, it includes the key length, it includes any PCR and locality constraints, it includes anything about the key flags, like what kind of signing key it is. Anything that a remote party might want to know about a TPM key is included in this certificate. And of course includes the public hacker key. And it is signed by an identity key. That means that if I trust an identity key, and we just had a previous protocol that said, if the endorsement key is for a good TPM, I know that this identity key is also for a good TPM. Well, now we know that if the identity key signs it, we know that this key is a non-migratable TPM key, and we know that those properties are accurate. And again, we can only certify keys that are actually loaded into the TPM, which is our way of guaranteeing that it's actually a legitimate TPM key. I will note, it is impossible to run the certify key command with a signing key or a legacy key. Don't do it. Don't trust a certify key credential that is signed by a signing key or a legacy key. Those are not trustworthy. Just because you can do it doesn't mean you should. So, that's the TCG certification design in a nutshell. That certified key credential, of course, you can have lots of them for lots of different keys. So once you've got your identity key, build as many as you like. Do we have any questions about that complicated certification infrastructure before we go on? This is probably the weirdest set that we've talked about today, so I just wanted to make sure everyone's comfortable with it. Okay, cool. So, the enterprise world. Enterprises generally seem to speak X509. At least that is what I am informed by the actual PKI experts. Certificate signing requests are self-signed. Certificates are entirely public. And as I said, CAs will often just push them out on the web themselves. In addition, the world is divided into CAs, which can certify anything, and other entities which certify nothing. This idea of a CA that only certifies its keys, which is to say the whole TPM model where it can self-certify things for this own TPM, it doesn't fit here at all. Unfortunately, these are the standard protocols supported by the commercial CAs. So you can already see, hopefully, how different the assumptions that are made in this commercial world are from the TPM assumptions. We're violating the assumption that certain certificates may need to be secret. We're violating the assumption that the TPM is authority on its own keys. We are living in a completely different world. So we can't even try and adapt to the other world by using X509 because almost every TPM key is incapable of creating a self-signed CSR. So no X509 certificate signing requests for us. A CA published certificate obviously breaks the PCA protocol. Whoops. And I will note that the only way to certify identity keys after we've provisioned them is to run that PCA protocol. So we're kind of dead in the water if we can't solve that unless we are willing to accept whatever provisioned identity keys we have for the life of the TPM. Some people are. We'd rather not live in that world if we can avoid it. And the certified key certificates mean that we've got a specialized CA, but nobody in an enterprise context is going to hand out CA certificates to anything that is not controlled by the IT department, because that's just begging for trouble, even if it's a TPM CA. And on top of that, the TPM certified credentials, those are not X509 certificates. They're a funky TPM exclusive format, so you can't even just drop them into applications, even if you could get somebody to certify your TPM as a CA. We've got lots of incompatibilities here. So, where do we go from there? The temporary patch here is certifying keys during provisioning, as I talked about before. You create the key, you walk the public key over to the CA in some fashion, and then you have the CA certify it itself. It doesn't take very much for most CAs to add a different certificate signing request format that happens to not be self-signed. It does take some change, but some CAs already support variations on this option. And realistically, this is a change we have to make no matter what because we need to certify our endorsement keys. So there you go. We are forced to make this minor change. Aren't we glad it's very minor? In the longer term, we'd really like to see extensions to the commercial CAs, or potentially what some folks have suggested, operating a separate CA in a different mode. I am completely agnostic on that. I'm not a certification person. So we are looking at adding a CA extension that treats certified key certificates as a kind of certificate signing request. Because the CA is already breaking down a data format to make sense of a certificate signing request. And frankly, a certified key credential is a lot more reliable and a lot more trustworthy than a standard X509 certificate signing request that doesn't tell you anything. So what we're looking at is saying, given a certified key credential, excuse me, we can turn around and issue an X509 cert that includes all of the details that were in that original certified key credential, but in a much more standard format. The PCA had to know how to interpret the funky format and verify the certificate chain. Everybody else can just say, I trust the CA, and that's good enough for me, so we don't need to treat the TPMs as their own CAs. Only the actual CA needs to understand how the self-certifying concept works. If we wanted to, we could even include the full certified key data structure in the optional data section of an X509 credential, so an application that does understand TPMs could make use of it. And if you're a legacy application and it's an optional field, just ignore it. This is for the certified key section. The AIKs, realistically, the only way to do it is to say, we've got to extend your CA. And you have to run that protocol. We don't have an option there. And you can't, realistically, we're actually expecting the second one of these suggestions to be implemented before the first. Because the second suggestion says, add a module that it understands different kind of signing request. The first one is speak a completely different protocol. You can't, it can't be a separate proxy, it can't be a separate module, it has to be really distinct. There are some folks talking to CA vendors sometime this summer about potentially getting these integrated. We'll see how that goes. There exists a PCA that has been implemented at I think OpenCA or OpenPCA, something like that. It is a privacy CA that will run the privacy CA protocol for absolutely anybody who comes along. They will even let you download their code, but realistically, most enterprises don't want an open source CA they found on the net. They want a commercial CA, so they want Microsoft CA to support their protocols. So I would expect that we will see certified key credentials used as signing requests before we see an actual real PCA module for a commercial CA, because there is a real protocol involved there. Even though it's not a very complicated protocol, most CAs were not designed to be that modular, from what we found. So for the AIK section?
Yeah.
Well, for the AIK protocol, that credential can be whatever format you like.
Okay.
So when I issue, if I'm a privacy CA running that protocol, yeah, I can issue X509 certs for the AIK. That one. Exactly. So basically, the PCA protocol, the problem isn't the certificate format, right, it's the protocol. Yeah. With the certified key credentials, there's two problems. One of which is the TPM a CA or not? And the second one of which is it's not an X509 cert. So that's part of why we can do that one as a CA module, where the CA is basically translating a TPM credential to a standard format, standard CA signed credential, versus the other one, which is not the certificate format that's the problem, it's the protocol that it needs to talk.